The following video exhibits the development process I use to design combustion systems for my customers. Let's take a look at what we got here.
This thing ain't no joke.
What's up, fellas? We're back out here at White Sands, and today we're going to do the jet fuel test. I have 1 gallon of fuel here that consists of 75% diesel and 25% naphtha. We're going to add it to this tank. We are going to do a propane assist ignition. We're going to start off with a propane fireball. We're going to slowly introduce the jet fuel, and we're going to retract the propane, and we will then dial up the power from there. Okay, so this is the first time that I've ever built a cyclone combustion system that runs on diesel or jet fuel of this size. I've built some smaller ones, and I do have videos of those contraptions, but this right here was a little unnerving because I've got some pretty loud bangs out of these things before in the past, but we didn't experience any of that in this particular test. So what we're looking at here is a process that I'm calling propane assist ignition. It's definitely going to make it cheaper than having some type of, expensive electronics and other pre-burner combustion systems and stuff like that. So what I'm doing is lighting the thing up first on propane and then turning on the liquid fuel, and then we retract the propane. In that first test, I didn't really like what I had seen. I'm not too happy with the internal vortex catcher. There is a 12-inch tube that goes down inside of this combustion chamber. You can see about 1 inch of the tube sticking out the front end of the burner there, and it's causing some combustion characteristics that I'm just not very fond of. I think we can do a lot better. So I do try it as is. I was just curious to see if that would give us any beneficial effects as far as fuel atomization is concerned. I was worried that we would struggle to properly atomize the fuel, or in this case, vaporize the fuel. So we're using the high temperatures of the combustion chamber as the actual atomization mechanism, the vaporization, I should say. So we're vaporizing the fuel with the high temperature combustion chamber, and it's still just see all the black smoke and all that coming out. It's choking itself out. I'm not very happy with the performance. I feel like we could do a lot better. So I do try it as is, but coming up here in a little bit, I just get fed up with the combustion characteristics, and I decide to just chop it out of there, which is common for me to do in these tests. I like to do rapid prototyping, where I'll just try a lot of things as fast as possible in a given test sequence. So we're going to give up on that, and we're going to chop this thing out. I totally smoked the yard out with this particular test, but we do get it squared away, and I think I try it like 3 or 4 times. I'm just kind of walking along with you guys here, narrating what we're seeing here. So again, I'm going to try another propane assist, and you have to stick the torch down in there with the propane lance at the same time, because the air from the blower blows it out. It is important to light it on extremely low airflows. Very low airflows are the only way you can get that internal combustion going with the propane. Because this is the first time that I've ever ran this system, you're actually watching me learn the machine. So this time I decided to let it heat up a little bit longer than before. I feel like I was a little premature in a couple of the other ignitions, but here we go again. I also do not know this valve yet. I'm just now learning the valve, so I don't know how much naphtha and diesel fuel mixture is actually going into the combustion system. I don't have a pump hooked up, so a flow meter is too heavily restricted with the current setup that I have. You can see there I got another flame out. I'm not really worried about levee explosions so much with this stuff, because the fumes aren't really very explosive. They can be, but I've worked around this stuff enough to know, when I'm in danger, I'll get up and get out of there. It does seem like in the beginning of this video that the burner's a failure. And you know, they say an artist should never show his painting until it's complete. So I'm breaking that law with this video because I wanted to bring you guys along for the terrifying ride of the development process, because it gets real scary when you get out there in the field and you start trying stuff and the damn thing doesn't work the way you want it to. It's very concerning. I'm losing time, I'm losing money, and I'm going to have an unhappy customer on my hands if I can't figure this out. So it is an exceptionally stressful time for me. I do get very worried, but you can see here we do get some fairly decent combustion going with it as is, but I just don't like what I'm seeing. I know for a fact that inner baffle is causing some undesirable combustion characteristics. One of the main problems being is we don't have enough pressure for the air input. The combustion gases and all that kind of limit the amount of air that can go into this space. We do get it running halfway decent right here, but I know it can do better. I just kind of have a sense for these things, and I feel like we could do a lot better than this. Notice how the front of the combustion system isn't really getting all that red hot. It probably would over time, but I just have a sense that we can get a far more stable burn if we cut that vortex catcher out of the cyclone. So we do end up doing that here in a minute. I finally just get sick of messing with it. I don't like the unstable combustion. And I also try to stab a piece of metal in there while the burner is running to stop the vortex from taking place. And it did seem to help a little bit, but it's just not what I had in mind. I want something that's a little bit more crisp and stable during operation. So we do have that problem, but other than that, it's not all bad. Here's the piece of metal I'm telling you about. The reason I stuck that in there is to stop that vacuum that's caused that goes inside the burner. Inside the center of that cyclone is a vacuum, so it actually pulls external air into the combustion chamber, kind of the way a tornado works. Inside of a tornado is a vacuum, and anytime you have spinning fuel like that, that'll happen. You can see here I've now caught the test stand on fire due to the radiant heat of the combustion chamber. So we're forced to shut it down, and neither of those ideas were very pleasing. Alright, I gotta do some surgery. I think I know what it wants. Alright, we just did a quick open heart surgery. Went ahead and cut that center rail out. We'll clean that up after we do another test. We're gonna fire this thing right back up. I'm not gonna give up so easy. I'm not gonna let this thing beat me today. Okay, we're back. Okay, test number 2. I immediately experience a far more stable combustion by having removed that internal vortex catcher. I'm already liking the way this thing's working. The propane's showing, you know, far better combustion characteristics already. I'm gonna let this thing heat up a little bit more this time before I jump right into it. It does do a lot better. Now my main struggle right here in this part of the process is I don't know how much fuel is coming out of that valve yet. I haven't learned the valve. You know, these are things you have to learn. So I'm being patient here, letting it heat up, and I'm just kind of going off what I see with the valve here. I'm looking for visual and audible cues as to whether or not I'm getting good fuel in there. One of the problems with this setup is not having a pump. There is a subtle pressure from the blower itself that is restricting the fuel flow from the tank. It's actually causing a back pressure, and I don't have enough pressure head on that fuel tank. I probably should have that fuel tank twice as high as it is, and it would give us better performance. You can see here I'm just kind of going through the motions. I'm testing, you know, seeing what's working here. So it does seem like I don't know what I'm doing. It's because I don't. It's the first time I've ever used this tool, and I am learning the tool at this point. So I'm just trying to figure out where that valve likes to be. And once I do learn it, though, I'm very quick to pick up on optimal settings and fuel to air ratios and things like that. So you can see right here, this isn't the worst setting in the world. I'm kind of blocking the camera here. I can't believe I didn't edit that part out, but I'm narrating after the fact. So this seems to be a pretty good position right here. As I said, I do not have a flow meter hooked up because the restrictions that it caused prohibit its use in a scenario like this without a pump. I did add a wand to the end of that combustion port bolt or lug, or plug is probably a better word for it. It's actually a plug. And we're still getting some pretty serious buffeting. But that's just because I haven't adjusted it the way that it can be adjusted properly. There's going to be a sweet spot where the fuel to air ratio gives optimal performance, and that's kind of what I'm messing around with here. But I will say this buffeting that we see is a characteristic of this type of combustion system because we don't have a fuel pump. Not having a fuel pump causes pressure cycles. We get an explosion, which reduces the fuel, and then we get an absence of fuel, which reduces the pressure, which allows more fuel to come in there. So it's not conducive to stable combustion. And I also want to point out that that flame does not look like that in person. What we are seeing is the frame rate of the camera is capturing, you know, these puffs that we're getting. It's a solid flame in person, and it is so bright that I can't look at it. It's an extremely bright flame. It does have a pretty powerful reverb. You can see right there, that's a pretty good flame right there though. Something a guy could definitely use in a process. I'm just going through the motions and trying out different settings to learn the burner. So it may seem erratic and appear as if I'm just not sure of what's going on here, but I'm rapid prototyping. Once again, I like to get in there and try a lot of settings really fast, get some instant feedback, and then adjust accordingly. I don't want to just let it sit here at one setting for, you know, even longer than 30 seconds because we are running out of this fuel mixture very fast. It wasn't cheap, and I don't want to keep wasting a bunch of money on this fuel mixture. I apologize for my narration talking over my voice in the video, but as I said, I'm doing this after the fact to kind of walk you guys along with what we're seeing here. I don't want to concern the customer with all this erratic nonsense that we're seeing. This is just part of my process.
This thing ain't no joke. I don't think the camera was picking up how bright those flashes are. That is a phenomenal performance. Now, if we hook a fuel pump up to this, that buffeting will stop. What happens is we get a big explosion, which reduces the fuel pressure. When the fuel pressure is reduced, less fuel comes in, so the fire backs off. The backing off of that pressure lets more fuel in, and it creates this throbbing effect. I've come across this before. Those flashes are so bright that it's blinding. You cannot look at that flame. It's blinding white hot. I think we're gonna light it up one more time for the sake of getting the hang of the procedure there. Probably not a very smart thing for me to be standing right there by that. I wish you guys could feel the power of this thing. It's pretty incredible. Okay, we're gonna try this again, see if I can do it without killing myself. That was every bit of a megawatt of power we saw.
Okay, we're going for another round here, and you may notice that it's a lot easier for me this time around to get things going. I'm picking up on this pretty quick. By the end of these tests, I will have a thorough procedure and order that I will be able to describe to the customer and get their employees or their staff, whoever's going to be running this thing, able to do this without any hazards or any difficulty. You can see there we've got the propane going already. Very quick.
Okay, I'm gonna let it heat up because the combustion chamber itself is acting as the fuel atomization mechanism. So we're gonna let it heat up.
And let's see what we can do here this time around. I feel like I've got this down. I'm learning that valve now. I know that valve has to be turned on a lot more than I thought before. You can see we've already got some fire going there. Kind of creepy, but if you rock that plug into place, it really is fairly safe to deal with. It's that glove can handle a blast from that flame without burning you. I've done it off camera, but just rocking the plug in place seems to work out very well. You can see we're already up and running here. And again, you're going to see some erratic combustion because I'm going through the motions here. I want to see what this thing does on different fuel to air ratios, and I got to do it as fast as possible because we are running out of fuel fast. So it's not that the burner won't run stable, it's that I'm trying to run it as powerful as possible with as much air to see what's going on. Wow, look at the thrust coming off of that thing. The odd shape of this flame is due to the vortex that we're creating. The fireball is spinning, so it has a vacuum column of air shooting into it, and the outside of it is being spun outward due to centrifugal force. So I wouldn't call that ideal combustion right there. I'm just looking at it to see what it does. You know, just kind of figuring out what is and isn't good here. Now, we could make that flame linear rather than a big fireball by adding a secondary cowling with some baffles in it. So there are a lot of things a guy could do to alter the combustion characteristics of that discharge flame itself. Adding more air will draw more of the combustion inside of the chamber. We are limited to about 1 psi of pressure with this blower, but I'm pretty sure we're coming nowhere near that because of the huge hole. That 1 psi is with, you know, a closed off end. So a better blower would drastically increase performance. This was the cheapest we could do with the allotted budget, and we're out of fuel. So, not too bad. All right, fellas, so what we just saw there was the development process of a combustion system that's never been built before. And I know it looked a little shaky, but this is my process. This is what I have to do sometimes to get these things to work. I just wanted to bring you guys along for the struggle. It's not always easy. So what we're gonna do next is, I do not like where this ignition port is at. So I'm gonna cap that off and weld it closed. And I'm gonna be moving the ignition port possibly to the back. Maybe right here or to the back. The back would probably be a good spot. I'm gonna give that a try. Now I know we've seen a lot of buffeting and a lot of, you know, erratic activity. I didn't really have time to dial the flame in. There are a couple of shots of the flame dialed in properly, and it's running really good. I was simply going up and down through the motions there to try and find what was the best. So we're going to be moving this port to the back. We're going to add a 1-inch cowling here on the front for the combustion discharge gases, and we're going to go from there. That's pretty much a wrap with this burner. For the specifications were definitely met as far as being able to burn that 29 liters. I could tell by the fireball we were doing every bit of that. After you've ran these things for, you know, 5-6 years like I have, you kind of get an idea of what a 500 kilowatt flame looks like, and pretty sure we were well within that region. So I'm going to add a couple of more things, and I'm going to test this thing one more time on just diesel. I'm running out of money here as far as the naphtha and all that. It should run the same, and we're going to go from there. But just wanted to bring you guys along for the struggle. It is not always easy, and it gets kind of frightening. So that's what we have. We got 2 changes. We will see this thing one more time, and we'll take another look at it and see what we can do. I'll be a little bit less erratic on the flame adjustments in the last video. If you look in the footage, you will see there were a couple of air to fuel ratios where the flame wasn't so erratic and unstable appearing. The camera frame rate is not picking this thing up. The flame is a lot more solid than it looks on camera.
the frame rate is kind of acting like, have you ever seen a helicopter on a camera where it looks like the blades aren't moving at all? We're getting a lot of that action going on there. So don't let the puffs concern you. I'm speaking to the customer, of course. It is a lot more stable in person. The camera frame rate is why it looks so erratic. So it is definitely altering it. And in practice, we're going to be adding another piece of pipe to this also. This blower is not intended to run this close to the combustion chamber. This is just a static breadboard test. This is not how this thing will be mounted in practice. And as far as the big fireball out in the front here, another piece of metal could be slid over this that will allow the flame to shoot out straight, especially if we put a couple of baffles in it. I'm not going to be able to do that on this particular project. That's something that will have to be done in-house. And if you guys can send me some pictures of the firebox this is going into, I can definitely give you some advice on how to cope with the flame size, because we do not want any flame impingement on the walls of the combustion chamber. That's usually not a good idea unless it's something that can glow red hot. Otherwise we'll get some soot buildup. We are going to need some secondary air blowing into this chamber as well. So that's where we are thus far.